Good morning, everyone. Today we're going to be looking at the plate tectonics theory, and we're going to be looking at all the evidence that we have. It's four of them only, but I believe one of the pictures is not included on the packet that I sent, right? So, just to start over here, this is the modern theory that explains how and why the plates are moving. Um, Also, this is the evidence that Alfred Wagner was eager to find and he couldn't, so therefore his theory was rejected. So this is evidence number one. We have the seafloor spreading. Evidence number two, on the other page, we have the mid-ocean ridge. And then evidence number three, we have the magnetic reversals. We flip the page and then we turn the composition book sideways. We can see the last one, evidence number four, which is the distribution of earthquakes and volcanoes. And we can see this is the one that we're missing. You're not gonna find them, but I will send a picture so you can just look at it. And I still want you to write it down just in case. They all have a little amount of information on the flip side of it. This is the theory of plate tectonics. This was the previous theory that we used to have, the theory of continental drift, where Alfred Wagner was the author of it, which no longer applies. This is the one that we currently use throughout the planet, so that way we can understand what is happening inside the Earth and why those plates are moving around. Okay, so evidence number one is called seafloor spreading. All right. Here, by the way, you have these pictures on about page, I think it's page number 6 from your packet that I sent, on the file that I sent to you. I can send you the file if you still don't have it. If you have a printer, you can print it. If not, I ask you guys to send me your information so that way I can send this packet home. All right. But these are the three pictures we're gonna be needing here. These three right here. Right. This one you can leave them there. This one you can leave them there. Don't lose them because we're gonna need them on the future. But these three are the ones that we're gonna need. So here you go. Let's go back and look at evidence number one, where it says seafloor spreading. And that's literally what it means. The floor underneath the sea is spreading apart. Remember those convection currents where those arrows show how the magma that loses density, becomes lighter, it goes all the way to the top, floats, right? And then as it hits the crust of the earth, this will be the crust of the earth, it spreads apart to the sides. As it spreads apart, it creates this. This is what we call the mid-ocean ridge. It's right there, the mid-ocean ridge, right? So as those continents, or I'm sorry, as those plates spread apart, magma comes out, and then it cools down because this is the ocean. You can see the ocean over here, and as the magma cools down, it creates new floor. So remember, these plates are moving away from each other. You can see the arrows. And as they move, the new floor is created as the magma that is coming out cools down. Now, as the plate moves away, as you move away from the ridge, this is the mid-ocean ridge, the floor is going to be getting older and older and older. Remember that the new floor is created right at the ridge. So the old floor is going to be away from it, right? This is what you need to write inside of it. Make sure you pause the video. This is the crust is older as the plates move away from the ridge. Right? There you go. There is the whole thing, so that way you can pause the video and write it down. This is where the hot magma over here is going up. All right, let's take a look at evidence number two. Evidence number two on the other page it says that this is the mid-ocean ridge. If you see the creation of a mid-ocean ridge, this is solid evidence that the plates are moving. And we saw that mid-ocean ridge on the previous example, right? This is the new floor close to the ridge, and this is the old floor away from the ridge. So make the little notes with your pen. Make these little marks with your pen also how the convection currents are actually pushing these two plates away from each other. Okay, this is evidence one, which is called seafloor spreading. It's moving apart, and as it moves apart, it creates a mid-ocean ridge right in the middle. It says right there. Okay, if I flip this one around, you will see that the mid-ocean ridge is the area where the plates are separating and magma is forming the new floor. All right, so here you go. Let's take a look at evidence number three. Evidence number three, I think I'm gonna send a whole video for you, and you're also gonna be creating a little activity with them. Evidence number three is called magnetic reversals. Magnetic reversals. Okay, that's a little complicated type of topic that you need to understand. But anyway, right now they're showing once again here how the magma is separating these two plates. At this point right now, we have a positive um, magnetism, right? The polarity of the section that is coming out from the inside of the earth, the magma, has a polarity of positive. But this one's with time, remember they're moving away with time. And as they move away with time, this is what scientists have found, that after a certain amount of distance, the polarity of the land changes. That is so weird. And by looking at the rate that the plates are separating, which is about 2 inches per year, that's how fast they're moving away from each other. They calculate the amount of time where they calculate the distance where the area that has changed polarity, and then they multiply that times the 2 inches per year that are moving, so they can calculate how much time it takes for the planet to switch polarity. And believe it or not, very soon we're gonna be getting to that point where our polarity in the planet will change again. Right, this is the mid-ocean ridge. This is the older material as you move away from the ridge, and those are the magnetic reversals that switch every so often. According to our note here, it says that the polarity of the earth is going to be switching, or is going to be reversing every 500,000 years. Yes, every half a million. Sorry, that will be every half a million years. 500,000. Any questions? Let's see if I can hold this. There you go. Okay. Now the last one, like I said before, this is evidence number 4. And evidence number 4 is the distribution of earthquakes and volcanoes. And by the way, is not coincidence, but all the earthquakes and volcanoes, by the way, let's take a look at the key says. Over here, the earthquakes, you can see that they have like a little blue dot, and the volcanoes are going to have a red little triangle. And if we look at the map, this is North America right here. You can see the yellow line is the edge of the plates. And you can see how all the earthquakes and volcanoes do happen to occur right at the edge of the plates. Solid evidence that tells you that when the continents move, earthquakes and volcanoes are created. Right? This is Africa and Europe. And once again, if you follow all the edge of the earthquakes and volcanoes, you can see that they're located right at the edge of the plates. Okay, you don't have the picture once again, but I do want you to write this down. Okay, about 99% of all earthquakes and volcanoes occur at the boundaries of the plates. Any questions? Okay, so the next video that I'm gonna be sending is we are gonna be creating this. This is a mid-ocean ridge. These are the magnetic reversals, and we're gonna be putting the amount of time that it takes for those magnetic reversals to take place. But that will be a separate video. For now, for today, I just want you to have all this together in your composition book. Now, where does this goes? This goes after the stuff that we did yesterday. Remember yesterday we were doing the earth plates and then the why and how these plates are moving. Well, just following after that page, you will do all this. All right, bye-bye.